Draw 3 more lines on this centimetre grid to complete the parallelogram with an area of 24 centimetres squared. So the area of a shape is the amount of space that it takes up, and the area of a parallelogram we work out in the same way as the area of a rectangle, so that's base times height. So we know that the base is 1, 2, 3, 4, 5, 6 centimetres, and the area is 24 centimetres squared. 6 times 4 is 24, so the height must be 4 centimetres. So we can go up 1, 2, 3, 4, but because we want to draw a parallelogram and not a rectangle, we need to move across. So if we move across one square this way, then we can complete our parallelogram. So from this point here, we go up 4 as well. And because we went 1 across here, we need to go 1 across here so that these two lines that we've drawn are parallel. Then we just draw our line at the top and we have our parallelogram. There are different possible solutions for this question, but as long as you've gone 4 up, then you will have got the mark for this question as long as you went across by the same amount each time. So here we went up 4 and then 1 to the right, and then from this point up 4, 1 to the right. And that way we know that these lines will be parallel, so we have a parallelogram. Carol counts the matches in 10 boxes. She works out that the mean number of matches in a box is 51. Here are her results for 9 boxes. Calculate how many matches are in the 10th box. So in this context, to find the mean, we would divide the total number of matches by the number of boxes. So the total number of matches divided by 10 is 51. And that means there must be 510 matches altogether, because 510 divided by 10 is 51. We can work that out because 51 times 10 is 510. So one way to solve this question is to find the total number of matches that we have in the 9 boxes we're given. So work out 49 plus 49 plus 49 plus 50 plus 50 and so on, and then subtract that answer from 510, because we know that there will be 510 matches altogether, because 510 divided by 10 is 51. But there is a quicker way to solve this problem. So here we have 3 boxes with 49 matches, and because there are 2 less than 51, that's 6 less or 6 fewer matches than there should be. Now here we have 2 boxes with 50 and 2 times 1, so 1 less than 51, so that's 2 fewer matches than there should be here. Then we have 51, so that's exactly what it should be. With 52, that's 1 more than it should be. And then we have 2 boxes with 54 matches. Because there should only be 51 in a box, because that's the mean, we have 3 more matches in each of these boxes, so that's 6 more matches altogether. So here we have 6 less and 2 less, so that's 8 less altogether, and here 1 more and 6 more, so that's 7 more. To balance that out, we need 1 more, so that the mean is 51. Because if we have 2 boxes with 52, we now have 2 boxes with 1 extra match, so that's 2 more, and then you can see that it balances out, so that means the mean is 51. A shop sells sheets of sticky labels. On each sheet there are 36 rows and 18 columns of labels. How many labels are there altogether on 45 sheets? Well, first we need to work out the number of labels on each sheet, and we can see that we have 18 labels in each row and we have 36 rows, So we can work out 36 times 18. So we can use column multiplication, and that gives us 648. So there are 648 labels on one sheet, but we want the number of labels on 45 sheets. So we need to multiply that number by 45. Again, we can use column multiplication, and that gives us 29,160. The diagram shows a pentagon. Each side of the pentagon is the same length. Is the shape a regular pentagon? Explain your answer. No, it's not a regular pentagon, because regular shapes have angles of the same size, not just sides of the same length. So although the sides are the same length, we can see that the angles are not the same. We have two angles of 150 degrees, two right angles, so that's angles of 90 degrees, and then we have angle A, which looks like an acute angle, so less than 90. Now we need to work out the size of angle A. So we know that a right angle is 90 degrees, so we can write 90 on our right angles. And we also need to remember that angles in a pentagon add up to 540 degrees. So to work out angle A, we can subtract all of our other angles from 540. When we're subtracting lots of things, sometimes it's easier to add up what we're subtracting. So 150 plus 150 is 300, 90 plus 90, 180, and then 300 plus 180 is 480, and if we subtract that from 540, we get 60. So the size of angle A is 60 degrees, and that looks about right, because we can see that it's an acute angle, so will be less than 90. Now the reason why angles in a pentagon add up to 540 degrees is because you can make three triangles from a pentagon, and we know that triangles have angles that add up to 180 degrees, and 3 times 180 is 540. So we could split this pentagon into three triangles. We know that each of the triangles will have angles which add up to 180. So if we've got three triangles, we'll have 3 times 180, so 540 degrees as the total of our angles in a pentagon. And every pentagon can be split into three triangles. So that's why angles in a pentagon add up to 540 degrees. The diagram shows three regular octagons joined together. There is a dot at the centre of each octagon. What fraction of the diagram is shaded? So we know that it's a regular octagon, which means that the sides will be the same length. So what we can do to make it easier is to split each octagon into 8 equal pieces. And then we know that when we're writing fractions, the numerator tells us how many pieces we have, and the denominator how many pieces there are altogether. That's how many equal sized pieces there are. So we have 4 pieces shaded and 24 equal sized pieces altogether. So we could write the fraction 4 over 24, and we'd get the mark for that, but we could simplify this fraction because both 4 and 24 are in the 4 times table. So if we divide both the numerator and denominator by 4, that gives us 1/6. On the centimetre square grid, draw a triangle that has an area of 5 centimetres squared. So the area of a shape is the amount of space that it takes up, and we find the area of a triangle by multiplying the base by the height and then dividing by 2. So we need to think what times what divided by 2 is 5. Well, 10 divided by 2 is 5. So if the base is 5 and the height is 2, 5 times 2 is 10. And then when we divide by 2, that gives us an area of 5 centimetres squared. So we can draw a triangle with a base of 5 centimetres, a height of 2 centimetres, and then we can join up our corners so we have a triangle with an area of 5 centimetres squared. Now it doesn't have to be a right-angled triangle. We could have a triangle like this, but again, because the base is still 5 and the height is still 2, the area is still 5 centimetres squared. Or we could have a triangle like this, or even one like this, because the question doesn't say you have to use the lines on the grid. We could also have a base of 2 and a height of 5, because that's still 2 times 5, so still 10. We could also have a triangle like this, because the base is still 2, the height is still 5, 2 times 5 is 10, but then with a triangle we find the area by dividing by 2, and 10 divided by 2 is 5. So this triangle has an area of 5 centimetres squared. Liam makes a sequence of numbers starting with 300. He subtracts 125 each time. Write the next two numbers in Liam's sequence. So 300 minus 125 is 175, and then 175 minus 125 is 50. So here we need to work out 50 minus 125. So the number that we're subtracting is larger than the number that we start with, which means our answer will be a negative number. On a number line, we can start at 50, and then if we subtract 50, that will take us to 0. But that's subtracting 50, and we want to subtract 125. So we need to subtract another 75, because if we subtract 50 and then another 75, that's subtracting 125 altogether. And 0 minus 75 is minus 75. So that's our missing number here. Notice we could work out 125 minus 50. That gives us 75, so tells us that from 0 we need to subtract 75 more. But if we can spot that our answer will be negative because the number we're subtracting is larger than the number we start with, we can just reverse the order, so work out 125 minus 50 and then make sure we have our negative sign. So now we need 125 less than minus 75. So if we subtract 125 from minus 75, that takes us to minus 200. Think, from minus 75, we've already gone back 75 from 0. So if we go back another 125, that will be going back 200 altogether. So our answer is minus 200. 5 miles is approximately equal to 8 kilometres. Complete the sentences below. 1 mile is approximately equal to how many kilometres? Well, 5 divided by 5 is 1, so we need to do the same to the kilometres and work out 8 divided by 5. We could write the division as a fraction, so 8 divided by 5 is the same as 8 over 5. And then we could change this improper fraction into a mixed number. 8 divided by 5 is 1 remainder 3, the denominator stays the same, so that's 1 3/5. We could also write our answer as a decimal, so 8 divided by 5 is 1.6, because 3/5 is the same as 6/10, so that's 6 as our 10th digit. Now, 1 kilometre is approximately equal to how many miles? So 8 divided by 8 is 1, so we need to divide the number of miles by 8 as well. 5 divided by 8 can be written 5 over 8 because a fraction is really a division. But if we were to divide 5 by 8, that would give us 0.625. So we could write our answer either as a fraction or as a decimal. There are 25 children in the lunch queue, including Nick. Nick says, there are twice as many children in front of me as there are behind me. How many children are in front of Nick? So if there are 25 children, including Nick, that means there are 24 children other than Nick. We know that there are twice as many in front of Nick as behind him, so we can draw a bar twice as large, and we know that our two bars will need to add up to 24, because there are 24 children other than Nick. Now in front, we can write 2 bars below, because there are twice as many in front as there are behind. So now we have 3 equal bars that give a total of 24. So if we divide 24, divide the total length by 3, that gives us 8. So we can write 8 in these bars here. And then we can see that in front of Nick, we have 8 plus 8. So that's 16. And then 8 children behind him. So that makes sense because 16 plus 8 is 24. And 16 is twice as many as 8. 2 times 8 is 16. So there are 16 children in front of Nick. What number is exactly halfway between 2 3/4 and 3 1/2? So this is a bit like comparing fractions. So what we can do is change these mixed numbers into improper fractions and then make the denominators the same so that we can compare them or find the number halfway between them. So 2 3/4 as an improper fraction is 11/4. 2 times 4 is 8, plus 3 is 11, and the denominator stays the same. 3 1/2 is the same as 7 halves. 3 times 2 is 6, plus 1 is 7, and again the denominator stays the same. But to compare fractions, or to find the number halfway between them, we need to make the denominators the same. Now 4 is in the 2 times table, so we can find an equivalent fraction for 7 halves with a denominator of 4. 2 times 2 is 4, 7 times 2 is 14. So we want the number halfway between 11/4 and 14/4. The number in the middle of 11 and 14 is 12 1/2, but we can't write 12 1/2 because we can't have a fraction within a fraction. So we need to find equivalent fractions for both of these. So let's try changing them to fractions with a denominator of 8. 4 times 2 is 8, 11 times 2 is 22, and 14 times 2 is 28. So the number right in the middle or halfway between 22 and 28 is 25. So our number is 25/8. We could write our answer as an improper fraction, or we could change it back into a mixed number. 25 divided by 8 is 3 remainder 1, so that's 3 1/8.